Okay. All right, so we're going to start up talk about the second one, and then we'll talk about the test a little bit. Anything else you all want to talk about? So for the second assignment, you're going to create a Jupyter notebook. And I say that we're what you're going to do, it's very simple. You're going to create a histogram of the values in a field. Now, you may not know what a histogram is, or you might, but we'll talk about that. So what I need to do first is to make sure I'm running Jupyter, which I'm not. So I need to start Jupyter up. And once I do that, I need to open up the Jupyter notebook that I have for this starter here. So the final exam script 2 starter.ipynb is the Jupyter notebook. Interactive Python notebook is what that stands for. So I'm going to click on that, and now I have my final exam script 2 starter. So this starter script works a lot the same way as my other starter script in that it shows you an example using random numbers. So here, I'm just setting up the libraries that I'll need. So I'm going to run that guy. And then here, I'm creating, in this cell, I'm creating a simple, this X is still just an array. So I'm taking an array, and the way I'm creating that array is to create a bunch of random numbers that exists in a standard random normal distribution. Okay. All right. So here's my array. It's a big array. It's got a bunch of numbers in it. The mean is going to be 100, and the standard deviation is 15. Those are the values that I've created. Okay. This is the cell that you'll replace, and that you'll put your own method for creating it. You're still going to create an array or list. Okay. So you're going to have, I'm going to run that one. You're going to have a cell where you do that. This cell, so I'm saying delete this cell and create your own cell where you're going to have all the values in one column be included in the result. So here I've just set up a way for you to reference a shapefile, or it could be a file in a geodatabase, and specify a column. But you have to write the rest of the code. And this column, I should just call this column name. So when you run that, and then finally, this code does what I want you to do. It creates a histogram based on the data. So when you run this, you get a histogram of whatever column you want. So a histogram shows frequency. And the things that determine a histogram are the number of bins and the data. So the number of bins determine how many bars there will be, because essentially this is a bar chart. So it will be how many bars there are. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 bars. So if I change this to 5 and ran it again, I would just get 5 bars. Okay. Or if I change it to 10, probably had 10 already. If I change it to 20 and run it, now I have 20 bars. I set it at 10 because the data that I gave you in the example data has 76 records in it. That's this data right here. So what you should do is create a histogram of either the average day from last spring frost, the latitude, the longitude, the elevation, or the distance to coast. To test your code, I'll run it on all of them. So you might want to run it on all of them. Okay. So here, what you really need to do is to create some logic that will collect all of the values in a field and store them in a variable x that represents a sequence that has all the values in that field. Okay? So it's pretty straightforward. The code for doing that is actually pretty much the exact same code that you've already created in this example. So you could do it either, that's what I'm trying to explain. This part of the code right here, you could do it either by building, either by using yeah. I guess I didn't put it there, but oh yeah. You'll need to add some more based on how you read feature classes. So basically you're going to create an array or a list of values, and all those values come from a feature class. So you can either do that through a search cursor, or you can do it through NumPy to feature class. I'm sorry, feature class to NumPy, as I've provided 2 examples for you already today. Okay, so this shouldn't take more than like maybe 5 to 10 lines of code differences in here, but you're going to modify this so that you get a column. I mean, sorry, so for a particular column, you get all the distribution of the values. So what I'm going to do actually is I'll post on the assignment when you turn it in, so that you'll have the correct answer. I'm going to post what your results should look like. So I'll post a histogram of all 5 of these columns. 1, 2, 3, 4, 5. I'll post a histogram of all 5 of those columns. That way you can test to make sure your script works correctly. So let's look at the assignment. It's graded in a similar but not the exact same way. So that's in here. So the grading will be the same, but with the following exceptions. Okay, rather than reporting a correlation coefficient, an elapse rate to the processing window, you're going to display the mean and the standard deviation values in the field in the notebook or on the plot of the histogram. So somewhere on the histogram, you need to put the standard deviation and the mean, or you can actually put another cell and just say, you know, mean is equal to 15, and then mean. So if we ran that, we'd just get, probably be better to say print the mean, oops, the mean is something like that. Okay, but you have to get the actual mean. So we've actually demonstrated a few different ways to get the mean. You can do that now. The most efficient way would be, since it's already an array or a list like object, to use the numpy.mean formula for doing that, and the numpy I forgot what it's called, but you can get the standard deviation of an array. So you could say numpy standard deviation. Yep, numpy.std. So you give it an array and it'll return the value. So you need to learn how to use a function like this.
We could also use that one line from the last code, right? They give you the slope. Well, no, it's not a line.
Yep. It's similar though in how it works. But this one you're actually gonna call functions. So you need to learn how to call the function or to create a function on your own. So we did cover how to calculate mean and standard deviation early in the course by using a function, but I don't expect you to do that here, but you could if you wanted to. So, so that's still plus 2 points. You can also get another 4 points by including a code, in your code, a histogram function. So this is the same as the above, but this is a little bit smaller function. Basically, if you rewrite this cell as a function and then call that function, you'll get this part. So including your histogram, a function that takes the data and returns the histogram plot. So this one actually has to have a return value, whereas this one did not need a return value. This is a function that needs a return value. So if you wanted to do that, you'd have to write something like def create histo, and then data, and then return histogram. Something like that. So all of this code actually creates the histogram. You're just going to put this inside of the function and make sure that you return the value that you need to return, which is basically the PLT object, the plot object. Okay. So up here, I asked you to correctly infer which sample area has the highest humidity. Here you're going to do, instead of that, you're going to make your code so that you can do a selection before you do the before you build the array. So in other words, if I want to select only those values where the average date to last spring frost are greater than 96, then I can do that. I'm going to leave the selection that you do up to you, but you do have to put a selection in. So you have to do a select statement. You have to have some sort of selection in your code. So you can either do that when you create the cursor, or if you're using a pandas data frame, you could do it in the pandas data frame method that we talked about last week. Probably a little bit easier to do in the cursor because we've talked about that more. You could actually do it, if you wanted to, you could even do it as using the select tool. So you could run the select tool first and then feed that feature class in as the input to that Jupyter notebook instead of feeding the raw feature class. Instead of feeding this feature class, you could run the select tool first, and it would select out a few. Okay. All right, and then since the script has no toolbox, there's no potential for the second deduction above. That's this one right here. So you will not. This just doesn't apply. It's not applicable. Okay, you're not going to build a toolbox. It's not part of the assignment. So don't worry about this particular one. It doesn't apply, but the rest of them do apply. So all the stuff about being late and that sort of thing apply. So, all right. That's pretty much the second example. Does anybody have questions about that second example?
So if we were to make a selection, you want the histogram to show that selection? Or do you want us to do that kind of afterwards?
Okay, by selection, I don't mean that it needs to like appear blue. That's not what I'm talking about. So I just mean that you need to take out the portion of the data that's not selected. In other words, you need to subset the data using the select tool, or when you create the search cursor, you can feed it. So search cursor Python ArcGIS. You see how you can feed it a where clause right here? Where clause. The where clause will limit what results come back. So you could feed it a where clause, and what that will do is it will only, if you say where the whatever value is less than 96, then it will only return those values that are less than 96.
Well, I guess what I was really asking is, you're going to show us examples of the histogram so we can compare our code to it. But if we make a selection that takes off everything under 96, would that change our histogram?
Yes, it will. So you will run your code on the entire data set, and then you will put an example of a correctly executed select statement in your code to get that credit, to get those extra points.
Okay.
Yep. All right. Any other questions?
And this is the take-home portion?
Yes. These two scripts together constitute the take-home portion of the exam, and they're due December 6th to get full credit. But even if you turn them in even if you turn them in 7 days late, you're only getting 7 points off. All right. So really, you have, today is Tuesday the 19th, and I know that Thanksgiving happens in here, but really you have 1, 2 weeks and 3 days to get it in. Well, you have till midnight on the 6th, so yeah, 3 days, 4 days really, to get that in considered on time. Does that make sense? So even if you didn't work, I was assuming that you would work on it very little this week, and you have over a week to do this. But if you do work on it over that holiday, then you'll have even more time to do it. But the way it's written, I'm sure there are some students that this should constitute, like I was picturing, if you basically understand the task, that this is a thing that would take a normal exam time, 2 or 3 hours at the most to actually complete. Now, if you have to do a lot of investigating and figuring out how things work again, it might take longer. I'm not saying it won't, but it's a project that you should be able to complete in 2 or 3 hours. Like that's the desired amount of time. All right.
Is there a study guide for the in-class exam?
The in-class exam, I started making a study guide, and I'll post that on Canvas before the end of the week, hopefully much before that. But the in-class portion is going to be really, really similar to the beginning, to the midterm, but the logical questions will be different, and that's probably what you're wanting that's probably why you're wanting the study guide. So the things I've already added to the study guide are that you'll need to understand the difference between the different types of search cursors, because that's on the test. The insert, update, and search cursor, but the different types of cursors, insert, update. There'll be a question that actually has you match a module and what it is used for. Like, so there'll be a description basically of the module. So for an example, I might say, this module allows you to execute ArcGIS tools inside of Python. And the correct answer would be ArcPy. Now, I actually have this set up in the test right now as a matching question. So it's not multiple choice. You'll have a list of modules and a list of descriptions. You'll have to match them up. And remember, this will be even easier because the whole test is open book. I don't think that part should be open book, but it will be open book. So you should be able to match those up pretty easily. But that is one of the questions on the test.
Just like ArcPy, none P.
Right. So the correct answer would be ArcPy. But if I said the module that allows you to manipulate and utilize arrays, then you'd say NumPy. Or if I said the module that does this, so it's only going to be the modules that we talked about. So it'll be I don't have an exhaustive list, but I'll put an exhaustive list on the study guide. But it'd be some of the built-in modules like math, NumPy, pandas, ArcPy, the ArcGIS API for Python, and that's all I can think about right now. But yeah, I'll put an exhaustive list on the study guide, and then yeah, so you should still understand what a function is, how to call it, and what gets returned. Even though we tested that pretty well on the first test, there's also going to be questions that require that knowledge on the second test. And then there'll be some code interpretation. So the code interpretation will be, this time it'll be more geared toward working with raster data sets and working with the data that's contained in the rows and columns of feature data sets, rather than just running tools, which is what the first one was kind of focused on. And yeah, I'll get that up and put that on there as well. And then there's the final project as well. That's not going to be due until the 13th. So you turn in the final project on the 13th. The final project, one of the reasons that I actually did this first script as a, one of the reasons that I did this first script as a, I did an example of something that you might do as a final project. So it does something, fairly simple, and it has a definite result. But basically, what I want you to do is your script, your final script, needs to run at least one ArcGIS tool. It needs to have either branching or looping in it. So in other words, there needs to be a for loop, and there needs to be a while loop, and it needs to have an if-then statement in it somewhere.
Wait, what are we talking about? You said there's a project?
Yeah, the project, final project.
What does that do?
So this is the description right here. Oh, it says May 10th. It's actually December 13th. So so that one's due December 13th. And they'll be responsible for creating a GIS program that automates the task. It's pretty general. So in order to get full credit here, the program has to implement branching, looping, and at least, I said 2 different tools, but I just said 1. I'm fine with just 1. Okay? So, and then you're just going to turn in a short description of what your tool does. So if your tool takes all the files in a directory and buffers every single file in a directory, then you need to write that's what my tool does. It does that. Now you would include the looping because you're going to loop through all the files in a directory. Okay? If you're, yeah, go ahead.
No, you go first. I have a question.
I was going to say if you're, and somebody could do that. Everybody could do that if they want. Okay? But you're gonna come up with it should be equivalent to a lab exercise assignment that does something. And you could go back and tweak one of the previous lab exercises if you want, but that's the answer. I mean that's the final project. All right, sorry, what was your question?
Oh, I was just going to ask, so mine's not a short description necessarily. I have to write a full 10 pages.
I should say not more than 10 pages. It should be smaller than that.
Okay, thanks.
Yeah. And the graduate, so Ashley, you should do something that answers a simple like research question. So if you want, I mean, you could even take you could take some of the correlation coefficient stuff that we talked about today, or some other type of charting, and take some data and show it, and you would describe why it's doing that.
Okay, so really the maps and figures is what would add up to a few different pages, not
Right.
necessarily a paper. Okay.
Yep, exactly.
Okay.
And yeah, and this final assignment can be based on this final assignment can be based on any previous lab. So you could take a lab and modify it a little bit, or you can create your own. But remember that it does have to include these concepts of branching and looping. So right now, even the final exam, the way it stands, script 2 and script 1, there's no real branching or looping in the script. So let's say you wanted to modify script 2 for the final project. You could make it so that you write a script that creates the histograms for every column in a loop. So you could write a loop that'll just do it for every single column. So it creates a histogram over and over and over again. Something like that. So that would qualify for your final project.
Okay. Yeah, I'm not going to lie. I saw that on 10 pages and I'm pretty nervous.
Yeah, I haven't modified this. I was planning to modify it before class, but I forgot that. So I'll update that. All right. Any other questions about that? I'm recording, all right? Yep.
I know you'll be. Oh, I'm sorry. You go first.
What do you got to ask a question, Ben?
When you're saying like it needs to be a tool, does that mean that it needs parameters as well, or what exactly is that saying?
Okay, so
Is that saying it needs to be a script tool that has?
this is the first time I've taught this course
Okay.
where interactive Python existed.
Okay.
So I'll change it to make this more clear, but you can turn it in as an interactive Python notebook, or you can turn it in as a script. I'll go ahead and make it so right now, because we're going to do it on the final exam, you do not have to turn it in as a script tool. You could just turn it in as a script if you wanted to. Okay, so we'll do it that way. You can turn it in as a toolbox, but we'll leave that part off. So you turn it in as a script or an interactive Python tool, and it'll be due to the 13th. Okay. Yeah. So
now, is there? I know you're going to make some modifications to that, but that's in the syllabus, right? All that information.
well, there's no syllabus online. This is the syllabus.
That's what I'm saying. Like, 'cause I missed the very first part where you pulled that up, and I'm trying to remember exactly how to get back to there.
Okay, so this is on the first page of the GitHub.
Very first page of GitHub.
Yep, the opening page of the GitHub. Yep. It'll be modified right there. Yeah, sorry, go ahead.
I was kind of wondering what your, I know, you're gonna take time off for Thanksgiving break, but, well, I'm gonna try to make this in project, again, based on my, thesis, so I might have a few questions to ask.
Yeah.
Will that be okay over Thanksgiving break to ask you some?
Yes. Yeah, I mean, I won't be like on my computer all the time, but I am like, I am going to be checking my computer every day. And so we could set up a time, we can like email back and forth maybe and say, hey, if there's a time you want to actually meet and talk, then we could do that.
Okay, that'd be perfect. Thank you.
Yep. And besides Thanksgiving, I don't think there's any day that I won't be spending some time working. So it's really not a problem at all.
Okay, awesome.
All right, any other questions?
Then if you draw that there, you're gonna make one grade out of all your different parts of the exam room, a lot of moving pieces.
Yeah. So, so for most of you are undergraduates right here. The formula for the lecture grade is that 45% is going to be the midterm, 50% is going to be the final, and 5% is going to be the 2 paragraphs that you write. Okay, so that's for your lecture grade. Now, I already said last week that I would allow the final to be double weighted. So what I meant by that is that the final gets twice the weight of the midterm instead of here they're almost equally weighted. So roughly, I'll calculate the numbers out, but roughly you could think of that as the midterm then becomes about a little less than 20, somewhere between 20 and 25%, and the midterm and the final becomes like about 75%. So whichever grade is better for you, that will end up happening. So I'm hoping that those people that maybe struggled a little bit on the midterm will do better on the final exam. So the final could be double weighted, and that will lessen the impact of the midterm exam. So whichever one works out. So in other words, let's say, I'm just pulling a number out, like even if you got a 50% on your final, that's only going to have, that's basically only going to have a small portion, relatively small portion of your overall grade then you got a B on the final. You probably still get a B in the class because it's weighted 75%, where this is only weighted 20 something percent, a little over 75%. Okay, so you have the opportunity to raise your grade up in the final exam.
And so if you did well on the midterm, and let's just say you bombed the final, it'll be flipped, just to say. I mean, I hope that doesn't happen, but let's just say.
Yeah, I mean, I guess I can do that. I didn't actually say that in class, but to be fair, I could do that as well. Like weight whichever one's better to be weighted more, I could weight more. I'm not totally discounting the grade, but it's a very small portion of your grade. Now the other thing I've done in the past, because most people, most people turn in most of the assignments, and so most people have a higher grade in the lab than they do in the lecture. So another thing that I've done in the past is average those two grades, so that you get the same grade in both classes, and it's a maybe a slightly higher grade than you got in one class and a slightly lower grade than you got in the other class.
So I'm a little confused about one thing, I think.
Oh yeah, go ahead.
Okay, so 5% on papers on the lecture side, 50% on the projects on the lab side. But they're both the same assignment, just different parts of it.
Exactly.
Okay.
Yep. Yep. Your final project is weighted a little bit more in the lab portion of the test, I mean of the class. Yes.
Where does the oh, never mind. Okay, thanks.
All right, any other questions?
And that doesn't apply to the graduate students with the changing of the weights of stuff. Or, I mean, I was just curious because I usually like to calculate it up before I take my final.
Yeah. It can be fine. I can do it I can do it for graduate students as well. You can figure out how bad your grade can be. That's what you're trying to talk about. I used to do that too.
Oh yeah, I always do that for every class. My minimum threshold.
Yeah. All right. Well, sounds good. So I will. I'll stop recording, and then I'm gonna modify the. After I stop recording, I'll modify the assignment as I said, and then those things will happen. So 2 weeks from today is the final written exam. You're gonna have 3 hours to do that. It's actually shorter than the first exam in terms of the number of questions. So you should have plenty of time to do it in 3 hours. So I extended, the time out 1 hour, plus I made it shorter. And then that following Friday is when the take-home scripts are due, and then the following Friday after that is when the final project is due. All right. So those are the outstanding items left in the class. And as Ashley asked another question on this, please contact me if you have questions. Don't hesitate to send me code that you have that you're working on. I'll be a little bit more reticent to provide a lot of help on the final project, but my answers to the final exam questions will be like, well, you should look up this type of thing, or you should look up that type of thing. It won't be like, oh, here's some code that'll help you. What I'll do is I'll post if I feel like I've answered a question that everybody could benefit from, that's a kind of a question about a concept, I'll post that as an announcement on Canvas so that everybody will have the opportunity to see the answer. All right?
Sorry if you said, but can you say on the test if we do use iPhone or computer?
Yeah, the test, you can use whatever resources are on the computer.
Okay.
And books and stuff, right?
Yep.
And the exam starts at 12:30, is that correct? Or is it at normal class time?
It's at normal class time.
Okay.
Yep. If that says 12:30 on the script, I mean does it say 12:30 on the syllabus? I got to change that.
I think it says 12:30 on the exam schedule. Like that's the school posted, so I was just making sure.
On the exam schedule, it should be just the last day of class. That's what once a week classes are.
Yeah, for block schedule, there's a separate, underneath those exam schedules, there's a separate one that's like block schedule, which is what this is, and it's the last day of class instead of the 10 week.
Yep. Do you understand what he's talking about, or you want me to bring that up?
Yeah. Oh, no.
Okay.
I was thinking of, I think, I had it written down at 12:30 for some reason, so. All right.
I'm not going anywhere. I mean, if you get here at 12:30, you'll probably be fine. You'll probably be able to do it in 2 hours, but try to get here at 11:30.
Oh, for sure.
And this one, since it's open everything, I'm not going to have a proctor. I'm just going to send the tests down. And I'm debating whether or not I'll send down a hard copy, or I might even just email them to you the day of, like at 11:30. Everybody will get an email. You complete it. You send it back. But we'll be connected through IBM if you want to ask questions.
Okay. And if you did want to send a hard copy, I can always print them off too.
Okay.
I have access to a printer.
Okay, I can do that too. Yeah. All right. Any other questions? I'll stop recording there, Ben.